You know what makes me happy. See that moving dots there in the background? That's the stuff we started on Thursday. So it's been running on the Raspberry since Thursday. Let me Nice, I think my SSH connection just died. So let's what the So I think this terminal actually nope. Show off. So this is a Raspberry Pi, and you see the background movement. Let's make this big and myself small, so it just stopped. So this has been running since Thursday, so stream overlays. Yeah, this is the way to go. That being said, I played over the weekend with a different setup because a good friend of mine who's also streaming gave me the idea that you could do the overlay in the cloud. So I played with that, and that's also working, but I still like this tool because I want to do the smart mirror also. And I mean, this kind of looks spiffy, but can we make this kind of useful? I mean, the other thing I realized is I can't show you, but I can use. Okay, I thought I can only use. Let's turn this off. Channel 1 for the picture-in-picture and the key overlay, but apparently I can use a different channel. So if I go here, actually, we have a source for the fill screen, so I can fill with camera 4. So actually, I'm not sure why. Oh, because camera 4 is off, I guess. So this is the overlay from camera 4, but I still have the picture-in-picture also from camera 4, which is a bit sad. Okay, forget that I said that. Still in warm-up mode, 5 minutes into the stream. Shall we get started? So, it's still running. So as usual, all the code is in the usual place in GitHub, and this is where we left on Thursday. So we added some dummy elements, and we loaded the. Well, actually, what's this? Okay, maybe you don't want to see that. And loaded the config from the YAML file, which was pretty cool. Shall we just? I need to go here and set the camera to 1. Ha! It's just so beautiful, isn't it? I mean, obviously I want the actual stream overlays and not some dummy data, so let's make this a bit more useful today. So to make it a bit more useful, if I just do a cargo run here, you remember we had this fake window, and it's all in the wrong place. So remember, big screen, well, big screen, small screen. Why is this not fading? Am I actually streaming the right stuff? So this should actually be a smooth transition. So I'm not sure what's going on here. Well, doesn't matter. So these two should be the same size. Obviously, when doing the layouting for my window, I don't want full screen because I can't have the editor next to it. So I thought what would be nice is to have like a smaller window. So basically a downscaled window of this for setup, and we're just gonna do even scaling factor. So let's just quickly check. Ooh, I forgot to actually add all the stuff we did last week to the Git repo, which is not good. Okay, let's actually put this to the repository so we start from a clean slate today. And actually, this is better, I hope. Yep. Sorry about this. After this long pause, I'm still not back into the mode, but coding. Why is this not fading? Ah, this is better, isn't it? Nice. Okay. Just to... So, we want this to be actually a small version of this so we can test the layouting and everything. So I thought about adding a scaling factor. I have no idea actually where to do that. So, I mean, probably the right place would be now to add the command line interface, parse the parameters and everything, but I'm just not ready to do that today, to be honest. So I guess we'll just hard code. Remember when we do the minifb, the frame buffer. Maybe we just hard code the scaling factor in there. And maybe we just, so this is the minifb version. Maybe we just want to set the size there. Maybe, I'm not 100% sure. I mean, in the end, I could just set this to the size. Let's clean step one. Clean this up a bit. The usual warm up. So width is this. Height is equals 360. So whenever going back to an old project that you haven't worked on for an hour, a day, a month, just doing minor cleanups is always a good way to handle this. So in theory, if I run this now, nothing should have changed, but I could just increase the size here and nothing. Maybe saving the file actually helps. Maybe saving helps. So picture is bigger now, and here you see we explicitly didn't want auto layouting because we know our screen size for the smart mirror, so just hard-coded values, no relative stuff, no need to be dynamic and resizable, but this was a good start. So what we do now basically is, so what I want is a scale. So what I want to do is a scale, and actually I want a big virtual buffer. So pretend we have full HD screen, but render into a smaller window. So let's say the downscale, and that is a U size explicitly. We only want by powers of 2, so 1, 2, 4, and so on. And probably we could get away with a bool that just says half size, but let's do downscale for the moment. And the downscale currently is set to 1, so don't downscale. So that still wouldn't change a thing, right? So what we actually want to do is, so remember what we did here in the next frame. We basically converted the 32-bit buffer into the 16-bit buffer. So basically we want the same here, right? I'm not sure. Wait, something. Oh, yeah. So basically we want one buffer that we give to the user. That's the buffer, and then we want to have the frame. So let's mirror that. I like that. So we have the buffer, which is what the user gets with, and then we have the actual frame, which is also just a vacuum 32. And for now, we just say frame vac initialize this with 0 width times height, and the scaling will come in there, and yeah, the Windows keyboard, remember my fun switching between keyboards? Yeah, Windows keyboard shortcuts for the win. So nothing done, but what we want to do is here we actually want to render with the frame and not the buffer. So buffer is what the user gets and frame is what goes to the screen. Naming could be a bit better here, but basically we get a black screen now because, hey, we're rendering to the buffer, but then we're rendering the frame. So to do handle downscale. So what we do for now is just basically we do what we do here. The classic, and all of this will be optimized, but let's get this stuff working first. So for every line, for every column, and this is stuff you write over and over, and basically the offset is y times self.width plus x, and then the pixel equals self.buffer O, and then we say self.frame. And this could actually be parallelized heavily, but I don't care. Self frame and the offset here is the same, so we just copy every pixel from the frame to the buffer. And this is just a mem copy, yes, but we want to do more. So it's working again. Obviously we want scaling, so this is the width and height. And let's assume we make this full HD by default, and to be configurable once we decide to add the command line parameters, but for now just so. Then we have ds for downscale equals 2, and then we say let w equals width divided by downscale. Actually, it's the inverse of the scale, but it's good enough. So this is a frame width, and this is a frame height. And now we have to be careful because this is a frame width and the frame height, and this is the frame width and the frame height. And if we do that now, obviously this will fail. So we turn right now the main question is right now we're iterating over the buffer size, and we actually want to iterate over the target pixels. So frame width is self.width divided by self. And we could cache these values, but right now I don't want to go too much into optimizing. Right now we're still into making. So this is the frame height. So we iterate over the frame height and over the frame width. And right now we handle only this two. I don't care about more. It's just so this is a source offset. And then we have the destination offset. Frame offset. Maybe these variables are too short, I must admit. So this is times the frame width plus x. And this is the frame offset. So we just iterate over the frame, and right now we'll just copy the upper left corner of the canvas, probably. Or we just panic because index out of bounds. So okay, I mean, we kind of expected that because why actually? I mean, it could be rounding errors. So step one, check which line it is, and that will be enough noise already, I guess. So it's probably in the last line we copy. So it's in line 270. 270. Why? 270 is odd. Okay. So, and now we say if y 270, let's say this, and no braces in. Sorry, too much C programming in the last week or so. So then we debug X. Probably this is one of the rare cases where we don't want the okay, it's Rust, so it's doing the right thing and not letting us. Width is 1080, right? And if we multiply that by 2, okay. So that's wait. Oh, width is 1900, sorry. So this is a number of pixels per line, 960, right? So 270 times 960 is this times 2 is exact. So it's exactly the last pixel on the. But why on line 270? What is FO in this case? Well, we know what FO is, but oh, no, that should be. That should be fine. So So we have 518400, and we have 960 pixels per line, so this should end up 540. Why do we divide by 2 twice? Something smells here. Why? Oh, maybe it helps to actually set the downscale. Okay, maybe remove a bit of the debug noise now. So it's 960 by 540. Wait, what? Oh, okay, because here we also need the... I'm actually, just to avoid... I mean, here we obviously want the width and the height of the frame buffer and not the height. Yeah, that's better. Okay, let's remove some of the debug noise because that's slowing things down so seriously. So now we're copying the upper left corner of the big buffer, and if you can see this is roughly half my screen now. Let's actually, okay, let's make the green block 960 would be the half the screen, and this is actually oh, let's use half the screen. So this is 960 by 540, and the red block is 960 by 540. Obviously the position is 962. Same here. And this is probably where a tool will come in, but for now we want manually editable. Let's just do the blocks for now, and actually let's run a release build. This copy here will be insanely bad in it. Whoa, race car out there. Insanely bad on a debug build, so yeah, maybe I want to... I'm not sure what... this was a Raspberry, so I wanted to go here and do a release. So debug builds tend to be insanely slow if you do stupid stuff like that, but we have a fully green window now, which is exactly what we expected, because while we're saying we wanted downscaling, actually what we did, and I just make this green block a tiny bit smaller here, so you see the black bars here, we're just copying the upper left corner, and obviously we don't want to copy the upper left corner, so basically what we want to do is actually, let's not interpolate anything, let's just take every other pixel. So if the downscale is 2, we multiply this y by the downscaling factor. And so if you imagine we have a 2x2 pixel block that we copy to this pixel, we're taking the upper left pixel of that, and it's not called ds. Actually, let's let ds equal self dot downscale, just for readability. Sometimes shorter names are more readable, so I'm not doing any sampling or filtering. We're just brutally skipping 3 out of 4 pixels. So take the upper left. So if this was a pixel, we just take this value and ignore these two, which for our test layout case is completely fine. So if I scp the config to the pi and scp the, well, maybe it helps to build the pi version. So this is here in the window. Let this run here, and let's run this. And if I switch to the other screen now, so basically this is exactly a downscaled version of that. So if I overlay that, you can see if I put it in the middle, it's exactly a smaller version of that. Let's disable the overlay. So you can nicely put this to the side, or put this to the side where you can see it, have your config file, maybe add some hot reloading later. You added your file, it's all scaled down, and that's actually quite nice. I like that. Sorry, needed a zip. We will add some filtering at some later point. Let's actually make this, put this back in the middle, right? And actually, I don't know, make this fill half the screen. Yeah, this will, let's see what happens. Because I think it's overwriting itself, which is a bit stupid, but let's make this randomly smaller. Nope, that was the wrong value. I think there's something else I want to get to today, so and let's tweak the scale just slightly so they kind of, yep, looks good to me. And then I can copy the config, and from now on we can share the config between both. To say both have the same virtual buffer size, which is nice. Simple, tiny steps, lay the groundworks, and it's still fast enough, so I mean, this is ridiculously slow, but we're touching every pixel in a very super inefficient way, so I mean, we could do super sampling if we wanted to, but I would like to extract that in a library, so to do handle multi-sampling, sampling for downscaling, basically what we would do, we would take all 4 pixels, add the red values, add the green values, add the blue values, divide them all by 4, mesh them together again. So what we could do is, for example, this would add the pixel right to it. Well, this is not gonna work because it's gonna overflow, and then the green and blue value is gonna overflow in the red value, and that's not what we want. I mean, but the very naive would be like this. This is wrong. This is overflowing, but I'm not sure we can. You can see the color. Can you see in the stream? Yeah, you can see it's the blue is overflowing and the green, and we're just lucky that so basically what we would need to do is basically, okay, let RGBA equal vector 0, 4. Right, and then we say RGBA and 0 plus equals pixel, and then remember we just steal from ourselves, so this gets the red value, right? So this gets the red value. Let's actually call this RGB ARGB and have the same order, so the red value is in the first byte, just for consistency. And yes, this needs to be a library and it needs to be fully parallelized, but just to... So basically this is take the components, put them into individual bytes, and we have to be careful here because we actually want to use 16. Because otherwise it might overflow, but if we put a byte into U16 here, oh, obviously this needs to be mutable, but let's remove this. Now the shifting on its own is not enough anymore. Now we actually need to mask the lower 8 bits, and so basically deconstruct the pixel, and I'm not sure if we even need to handle alpha. I don't care, and then at the end we just say, okay, let pixel equal, and then we do the reverse basically. Well, this is RGB 565, so let's do RGB 888. So basically this is RGB 0, which we skip. This one we shift, we only want the lower 8-bit. We want the lower 8-bit, and then we want to shift that by 16-bit. That's the space where the red goes. And then we basically OR that together with the green, which is only shifted 8. And yes, this shift 0 is technically not needed, but Let's actually... I like symmetry, so... Hmm? Oh. Yeah, it's telling me it's not needing this brace here. But I like it to have the... Why is it not complaining here? Okay, let's remove this. So right now we did nothing differently. We decomposed this one pixel and recomposed it. Why is pixel hue? Oh. So unfortunately, let's cheat here. Let's use the U32 here. Yes, wasting some memory, but this should be some vectorized code anyway in the end. So nothing changed. We decompose every pixel and recompose every pixel, which doesn't make any sense whatsoever. But the nice thing is now we can just say, okay, let's take the pixel to the right of it. So remember, this is the upper left corner of the 2x2 block. And yes, we have a hard-coded downscale. Assume a hard-coded downscale of factor for multi-sampling. So basically now we say, okay, and now we say for element in RGBE. Nah, I'm not gonna. We just divide it by 2. So we add the 2 pixels. We put it from a byte, from a U8 into U32. So even if we add 2, we cannot overflow. The U16 would have been enough, but then this shifting would have needed an S. And then we divide by 2, so basically take the average out of these 2 pixels. And as you can see, in the horizontal direction, it's already filtered now. And then we could just brute force and say, so, okay, what's the next line? Oh, it's obviously plus the self dot width. Oh, no plus here for the first one, but then it's self and this is total overkill. It's just proving. Right now we're adding 4 pixels, so so now you see these little dots are actual squares. I wouldn't recommend doing that. It's just a layouting help, so but we have very, very super simplistic multisampling now. And highly inefficient code. And maybe let's not do this, sorry. But profiling optimization, step 1, get it to work, step 2, optimize it. So obviously we could use streaming functionality that probably could do like 16 pixels in one instruction instead of 16 instructions. I hope you don't hear that noise. My neighbors seem to be drilling holes in the wall. Yeah. So but basically this is the scaling we wanted to do. And I mean this is config and this is just the scaling. And yes, full HD is hard coded, but we'll fix that once we handle command line parsing. So added 2x downscaling with multi-sampling for minifb window. Done. Stream good. Bye bye. Love you all. I'm out. Ciao. No, I'm joking. What I really wanted to do is, I mean, come on, really? This. Yeah, it's cute. It shows we can update, it shows we can render, it shows how alignment works, but is this actually the overlay I want for the stream? And actually, my color is off. Let me do something real quick. And this is not the right green. So is this really what I want? No, I want my nice little stream bug in the corner, and I want actually, yeah, let's turn this off. I want down here. I want down here. I want the overlay for the golds, and I want my pop-ups for subscriptions and stuff. So I want images. So let's turn this off. Let's make myself small. And what I actually want is so what I actually want is, let's say file new, and the width is, let's say we want kind of half the stream size up until roughly here, and about this high for the banner down there. So let's say we want 960 by, tempted to say 128, but let's get out of this coda sizes. So why am I using GIMP? Didn't I switch to Krita a while back? So I haven't done this in a while, so I'm just creating a dummy overlay right now real quick. So, oh, they changed the interface. So I want a gradient. This is actually, colors, levels. And we could just squeeze this a bit. I just want a gradient that fades out to the right side, and maybe we squeeze the top a bit. I just want this tiny bit of transparency to the right end of it. Obviously, I want this in the alpha channel, so Wait, we have an alpha channel. Grayscale copy of layer sounds good. So we have this fading now. Obviously, we want this to just be. Let's be daring today. Let's not use green. Let's not use anything greenish. Let's stick with purplish. All these colors are awfully wrong on my screen. I need some calibration. Okay, so all I'm going to do is say edit, fill with foreground color. And that's it. So we have this semi-transparent thingy. And do you want it a bit fancy? Do we want it a bit? I'm still not happy with the curves here. So colors, curves. All I'm looking for is having a slight bit here, but nope. I'm gonna use level again. Thing is, I want it on the right side. I want it very far right, but I want it very harsh there. So something like this. So lots of space to put text, but then very quick fade out. Yeah, this is good. File, save. Data, work, Cheval. Can I get a new folder, please? I'll create folder data. And we call this banner.xcf. And actually, I'm not going to handle xcf, so I'm going to export this as banner.png. And let's get out of GIMP. So open data, banner.png. Yep, wrong screen, but basically this is our stream banner that then we want in the lower left corner here. Hopefully alpha blended. That's why I put the alpha in. Maybe the color was not the smartest idea, but let's add this data to Git to have some test data. And basically what I want, okay, over the whole thing at the very end, what do we want to do? So we want this to be named banner background. We want the type to be image. We want the parameters to be pos x is fine. I think we should always have a pos. Sorry about that. Very dry air here. Very, very dry air. So the position x, it's the far left, so it's 0. The position y is I mean, we want 1080, we want a little bit of space at the bottom, and just for, I don't want this overlay to overlay the overlay, so I'm putting it actually above, so let's say, we can experiment with it, but basically it's, I usually would use 1080 minus 20 border minus the height of it, and maybe we need a minus mode there to actually, let's touch to do .md. Oops. Add more position modes, e.g. Negative values for from bottom Right. Just starting to gather ideas now. So basically position is 920, and we said we wanted quite a bit up to be above my actual stream banner. So let's just put it at 600 by 20. Let's not give it a width. Let's say default width is image width. Default height is image height. Image height, we don't need an offset. We don't colorize it. This is it. Oh, maybe we should give it the file name. So the file name is data banner.png. We need to be a bit careful when copying that over to the Pi, but that's for another day. So this is the config. This looks straightforward. Everybody can edit that. So if I run this now, well, oops, unsupported element type image. Well, true. But I was interested in the config, and the config. Nope. Oh, we don't handle string. There it is. So this is the config element, but we don't handle strings in the element config yet. So want to do strings first or the element first? Let's do the strings first. So element rs, and we have the config here, and we have the set u32, and we have the set, but we don't have we do have a string, right? We do have a string. Did I just... Oh wait, it's here. This is actually the config that we're outputting here, so it's all there. We're just not using it. So how do we add an element? I mean, shall we just cheat again? Let's use the block element. So how do we add an element? We create an empty file, and all of these will be in a library. So and add source image element. So let's copy the block element, open the image element, and step one is just brute force search and replace, and the name here is image, and then we have the element factory, and yes, I know the parameters are wrong, but step one, copy, brute force straightforward copy. Then we actually go into the main, we go into the lib and just add it here, pop mod image element. So now it's at least, probably we've got something, so, oh, and we did forget. Obviously this should return an image element and not a block element, which just doesn't know anything about. So we added it, it compiles, and it does exactly nothing. Well, because our Cheval here says onload. I have no idea what you're talking about, so step one, and this will come from a library, and this is a point where I'm getting tired of cutting and pasting and renaming, so it's imminent that I'm gonna fix this. So we have an image element factory, and here we just say, okay, So we create an image element and it's just in our box and nothing happened. Okay, because our element config didn't have a size and the image element, I mean, that means our width and our height is 0, which is not what we want, cause so let's just give this a default, let's say 800 by 200 and a different color here, different color, just to see it. So this is our overlay which we just added. Obviously we don't want a block. If we wanted a block we would use a block. So step 1, you want the file name, and that is a string we own. So in the factory we have a file name. That's nothing to string. And actually here, wait. Here we have the element config, and obviously we want to have a get for strings. We never use that, so we say get string or, and this is not the type string, this is the so by default we get a string reference and we return a string reference. No need to copy, and then we say if element config is actually a string and this is an S, then we return a reference to S. Oh, it's string, not string, sorry. Mixed the variable name with I'm not sure if I want to. Yeah, I probably, actually we want to return an actual string, and here we just say s.clone. It compiled. So here we want to say we don't have a color, and let's keep the color there. So self.filename equals get string or, so still running, still doing the wrong thing. Which is nice, but now we have the file name in here. So what we actually want to do, if self.filename not equals nothing. So this is a case where we actually load an image, and I'm not gonna load the PNG myself. We did have, what did we use for, what did we use for OMT? Remember, we had this atlas tool in OMT that used, what was the crate we used for images? PNG, image. Okay, too simple. Maybe we just use the image crate. basic filters, decoders, yeah, PNG, JPEG, GIF, BMP, ICO, TIFF, this, Farbfeld. Okay. This looks good, so step 1, add this to our cargo file. Pulling in a ton of dependencies. So while this pulls in, what's a sample of loading? Image buffer. Dynamic image. So we just probably have a, so that still works. Compiling took a while, but opening and saving image. So basically we can open the image. Error handling is a good point. And then we can access the pixels. Right. Right. So obviously we have to be a bit careful here. I'm not sure if I want to use a generic image or the dynamic image here. There was something, 2 million users, yeah, this crate should be stable. So basically we say if we have a file name, then let's try to load that. And right now I think I'm fine with panicking, so to do add clean error handling, which I can't be bothered with right now. If I do a cargo check now, it will tell me that I forgot to... Wait, what? Why is this... What I don't get is, why is this even compiling if we never said... Interesting. Um, what? I just want to break it. Okay. Why is it finding... Oh, image is... Okay. Okay, fair enough. So what we want to have here is image, and that's an option of a dynamic image. I forgot why we had to use dynamic image, but there was a reason, and so self dot image equals some image, right? We have a image. Okay, obviously by default we have no image, right? So, oh, there's no formatter. That makes me sad now. Have we just lost this because of this? The problem is, so if you remember the element here, we could just do this. I mean, ideal would be just wouldn't it be perfect if we could just say, okay, we implement a formatter for the dynamic image and we're done, right? But we cannot implement a trait for a different crate, so we cannot implement the formatter for the frickin' thing. So instead, we have to implement the formatter, and I'm gonna do this here because it's close to the structure for the image element. And this means this is gonna go, and here we just do to do, because this means we have to add them all manually. I'm sure there's a smarter way, but for now I don't care. I just want this to render. If I run release now, it still works, and in theory, if I go to the config here and put a... What key was that? We had that before, and just put a broken file name here, then the unwrap fails, and then everything falls apart, which is good enough for me now. So if all of this works, then we say, and probably, yeah, let's do the calculations here. Then self.width equals image.dimensions.0. And you know what is coming? Yes? You know? Wasn't it dimensions? Didn't we just emg.dimensions? Wait, what? Oh, okay. Can I just please copy this? No. uh, it's actually telling me what to do, and then not allowing me to auto. Okay, this is fine. This was not helpful. This was not helpful at all. Okay, now we have the correct image dimensions. We still don't render the image, but we take the dimensions from the file, which is nice. So actually in render, I'm just gonna say match self dot image. If we have none, then we just do this here. And yes, it's time to move this block rendering stuff in the library, but and if we have some image, then we do nothing with it. Don't like the expected fat arrow. Yeah. Oh. So if we don't have an image, we just render our dummy block, and otherwise we do nothing. So what we can do here is that this is straightforward, right? Too much cut and paste. So okay, step one, remove these ugly spaces here. Where do they actually, they were there. Okay, so in both cases render the dummy block, nothing gained, just verifying it's still working. So we're rendering the dummy block, but now comes the magic. Instead of this, we say, how do we actually access the pixels inside in? We have a get pixel for x, y. Okay. We have a get pixel for x, y on the image. Let pixel equal image get pixel, and actually, yeah, x and y is correct. And what format is pixel in? RGB data. Okay. I am pretty sure there's a cleaner way of doing. I mean, it doesn't need to be mutable. And here we just say, okay, we want the raw RGB data. Why can't we? No? So data now. Okay. And now, funnily enough, if we go to our minifb, remember this code that combines an array into a pixel? Guess what? Guess what? This is gonna be so much reuse. And this is, let's call this ARGB. Probably the order is wrong. Why is he? Oh. This is ugly. Let's check if the image library has a helper to get this as an actual. So it's BGRA, RGBA. So it has a from. What is a pixel actually? I don't like this. Hmm. 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 Just looking at OMT, how we copied the pixels out. So pixel is actually an array, so I think this actually, didn't we just look at this? Okay. So this actually is the array, so and then we have to do the as u32, as u32, as u32, and that needs some extra braces. This is why you put all of this in helper functions. So, but for today, so we're overwriting the background. So this is roughly what we want, and the green is transparent, which is correct. But we're not blending with the background is our main problem currently. Let's actually build the ARM version. I want to test something. I can stop this. Come on. Come on. Come on, come on, come on. Come on. So we SCP and probably we copy the config. We copy the binary. We copy -r data. Yeah, probably that was too much, but ooh, what? Oh, because there was a data directory. Okay, let's just run this. So it's running, it's not crashing. And we have the banner there. Oh, come on, it's not this hard. We have the banner here. So we need to handle transparency, which basically means mix with the background. But apart from that, if I go here and do this, and we have kind of the green. Oh, sorry. We have the green up there, so it's a little bit transparent here, so that works. I'm wondering. Oh, the Kia is not doing alpha, so we only have like. Oh, it's kind of working. I mean, obviously the blending here is a pure accident because the color is wrong. It's not actually blending. Let's turn this off. Mm, copy banner.xcf to banner test.xcf. Can you open GIMP, please? Yes, please. So, obviously our colors were wrong because this is purple and the other one was it's okay. So let's take a perfect red. Perfect red. And make a nice little perfect red. Oh, red dot here in the upper left corner. So red. And let's take a perfect green. And green is a very bad idea for the Kia, but for us, let's put a perfect green. And yes, I could just, but you know, let's take a perfect blue. So this is a perfect blue. And now what I actually want to do is I'm just gonna cut some holes in this. Gonna save this. I'm gonna export this. Gonna quit this. Gonna go into my config file and just put a second copy of this on the right side of the screen. So if I run this now, I see that my colors are wrong. Because this is probably B. So this should be red, so red and blue is swapped. So red and blue is swapped. So this should be red, and maybe that's already everything, but so red is correct. This should be green. Okay, wait. Wait a second. We know what it is, right? So it's blue, green, R, alpha. So it's blue, green, R, alpha. Blue, green, R. Wait, what? Okay. Let's just say this is just one of the colors, right? This is not the red channel. This is the alpha channel. So if you look at it, holds black, fading out and everything. So this is the alpha channel. So if it's ARGB, this should be the red channel, right? Nope. This is the, this is blue. This was blue because this is purple that has blue, and this is blue. So this is the 2 is the blue channel. 2 is blue. So this is 2, and this should be red. Right? Upper left corner red. Upper left corner red, and the purple has some red in it. So can you? I would love to edit this, but my editor just doesn't like me. Where's my... You see that? My highlighting is gone. I mean, I can't do this. I'm not sure how I managed to do that, and then this is probably... Ah! Typing without a cursor is hard. What the... Uh-oh. What the hell is going on? Now I'm gonna have 500 open windows. I'm gonna fade you to black real quick, because there's stuff I cannot show to you that might be in Sublime. Okay, we're good to go again. So cursor is back, so this is 1. Let's just see if the colors are correct. What's going on? Okay, so this is minus the alpha, but this is basically red, red, green, green, blue, blue, purple, purple. So this is what we wanted. So I will say that the alpha channel actually, let's say this is A for alpha, and this is channel we want to mix. So basically what we need now is some mixer, right? So we're gonna chicken out. So this is the alpha channel. So now we have ARGB, but when setting the pixel, we ignore the alpha, right? Let's actually put this up here, and you open the window on the wrong screen, but basically we ignore the alpha, right? And this is, the colors here are correct now too. So, and let's assume pre-multiplied alpha, so mix. We did have a mixing function that we wrote before, so Why can't you not find this? So basically we're gonna steal this from the other project. And yes, this should be this is from OMT, and I'm not gonna write this again. But basically blends A over B with percent, so it disassembles the pixel A into RGBA. Wait, this is RGBA and we have ARGB. This is not needed. Oh, okay. I'm just too lazy to type, so this assumes currently RGBA, while we have ARGB, because this is alpha, red, green, blue, so obviously the mix needs to be yeah, this is RGBA and we want ARGB, so but that is easy to wait. That is no. Okay. So we have alpha first, and then everything's offset, so that's 24, this is 16, this is 8, this is 0. And then the same for the second component. And yes, it's time to get this into a library so I don't have to log it around. We want to remove the mixing. Let's just leave the mixing factor in, and then basically here we have the same. So we shift this whole thing around by 1, and then we shift this. You just say ARGB. So now we can mix two U32s. So basically what we say, let pixel equals self dot, is it even, it doesn't even get self, so it gets image element mix ARGB, which is a clear sign for a helper mix ARGB. And what are we mixing? We're mixing the pixel, so it mixes A over B, so A in front, pixel, old pixel to be done, and we just want 100% for now. Right, so what is old pixel? Old pixel is basically let old pixel equals buffer. Oh, and this is gonna be so slow. Hey, this is read from the old position and get the new pixel reformatted. Not a fan of this construct here, but then mix it and then override it. Bitmagic. Do you love Bitmagic as much as I do? And obviously we messed that up. Let's try something. So if I set this to 0, then it should be invisible. Why is it green? Why is this green? Wait. Wait. Why is this green? I mean, if we do 0.5 here, 50-50. Oh, okay. It is ignoring the holes because obviously mix ARGB with alpha. Obviously, what we forgot, and now it's gonna get ugly, because this is an alpha value. Actually, we want to multiply. Oh my goodness. This is too much for today. Actually, what we want is, okay, now it's gonna be function mix byte. The mix byte, we have 1 byte. We have the second byte, and we have the mixing factor in U8, and what we want is U8, right? So what we want is we want this as an F32 and divide by 255, right? Too much C code. Then we have float A is A as F32 multiplied by F. So we multiply the foreground by the alpha. Let's assume we don't have pre-multiplied alpha at the moment, and then we have float B equals B as F32 multiplied by 1.0 minus F, right? And then we return F plus FA plus FB as U8, correct? And then instead we say let R equal image element mix byte R RA RB AA, right? RGB RGB, and this whole block becomes obsolete, but that means the F here becomes obsolete, which I won't fix right now. And then we do SU32 here, right? So we mix the individual bytes using the source alpha and the destination alpha. We actually don't give a shit. gonna be so broken. So the holds are correct now. So we have the nice blending here, and we do have the holds. What I'm not getting is the image should be blended after the colored blocks. So I expect this color to be this color, and I expect to see the dots through this whole thing, right? I mean, let's make this a bit more clear. We move this by, I don't know, 480. Oh, no, that's the wrong one. You move this to 480 and this actually to 540, which is half screen minus 50, so 490. Am I doing this math right? So I would expect to see through this hole, see the green and the white, see the green and the white, see the red and the blue, and see the red and the blue and see the dots. So where the hell is this green coming from? Oh, did you see that there? Let me undo this. This is a 0 and not a O. So we're always reading the upper left corner pixel, which is not what we wanted. Ooh, look, overlays and holds. Overlays and holds. I want to see this on the arm. Oh, I have to stop it, and actually we have to build it first before we copy it. And then we copy the binary over. We copy the data over. And we copy the config over. Yeah, that needs a better way of doing it. So we have the two images here, and this is becoming slow, so we need to get into performance testing mode at some point, but you cannot see this, but here's a nice gradient, and here are the holds. And sorry for my green screen tweaking out, but you see what I'm getting at. So if I go back here and use this as an overlay now, we're getting awfully close to what we want. Maybe it's time to make the test blocks a bit less obtrusive. Let's do that. So let's stop this, and I'm gonna put the test blocks, let's just make them smaller. And this is probably, we need I want a minus 96 now, but and it's 1844. And say, so this is 1080 minus 54, 1026. Oops, where did I? Yeah, let's. Okay. This needs to be an O. Sorry about that. What did we say? Position is 1026. White block, blue block is the combination of these. So position is 1844 and 1026, and I probably totally messed that up, so let's oh, I just realized I edited the file on the, no, I just had the wrong window open. I hope to have the blocks in the corners, yeah. So the blocks are in the corners. The right offset seems to be 1824. I'm not sure what I calculated there, but so we have the blocks in the corner as corner markers, and actually I'm gonna make them the pure colors. I just want to see what's the absolute limit of the output. This is nice, and then I put the banners. Actually, let's scp that config file over and see what happens. That's not too bad. So, oh, maybe we need to fill the background. Maybe this green block here should actually be a background filler because of keying. So basically, we call this green background block and make it the full size again. Right, so if I run this locally, I get the green, copy the config over, I run this. So this is more what I like, and I get the nice gradient. So if I overlay this now, ignoring that we can't do gradients for the moment. I mean, obviously here the holds work nicely, but the gradients obviously can't work. But that's a fixable problem, because if we only have hard alpha, then let me turn this off for the moment. Instead of a chroma key, we can use fill source camera 1 and then put a media key uploaded in here. Right? So if I go this here, so we can upload the key into the blah. So basically, the fill source stays the camera, so we stay dynamic, but we bake the mask. We bake the key source into this, and that should be fine then. I mean, this is actually, I'm a bit worried about the washed out edges here. You can see it on the stream too, so. But that might be a bad HD. It shouldn't be a bad cable. So maybe we just need to go half resolution for this one. And obviously our green test color here is not working, but this could work nicely for overlays. And we can have multiple over each other, so that's fine for me. That's actually okay. Atem remote control is for much later. I actually... Here is what I'm gonna do. We have the element conf. Oh wait, we have the cheval config element, the name, the type, and then we have disabled bool. Will this actually just... I'm not sure what it defaults to. Okay, so this doesn't... I want this to be optional, so I'm gonna go real quick into the... We're doing far too much stuff today. So Serda documentation. Maybe I want the... I want macros. No. Where's the rename defined? Serda JSON rename. Where are actually Rust Serda default values? Serda default. Serda default false? Ah. I'm pretty sure that's... Does it have to be? Okay. So we're actually telling it to use a function. I mean, I don't want this here, but basically we say default. Let's say default bool false, and then call this bool. I had hoped there's an easier way, but okay, so this changed nothing, but in our cheval on the if e disabled, then continue. If this flag is set, just ignore this completely. I don't want to start commenting out stuff in the config file, so this is nice, and now I want to roughly where this banner here is. I mean, I could just cheat and check. I cannot because it's in HTML. Oh, I can because 800 by 100 has a padding of 10 and no position. Wait, where's the positioning? I mean, I want to get rid of this, so let's just guess the position. So I want it to be slightly from the left. I want it further down. I want some extra space. It's 100 high. So it's 1080. It would be, we said 980, then minus the 10, then minus some extra. This looks round about right, so let's do a build of the arm. SCP the config, SCP the binary, and start the binary on the Pi. So if I overlay this now, it's obviously under the other overlay, but this is where, so this here, the purple one down here, purple one down there, is where we want our text to be. I wish HDMI had an alpha channel. I really wish HDMI had an alpha channel, and this could be so cool. And then let's just play this through a bit more. Let's stop this. I'm going to move this up again because so let's say we don't have text, which kind of banner title, banner title to be done. Actually, let's try something. File, new, yeah. 500 by 50, random. So 500 by 50. And we add some text, we make it white and black. Let's start with size of 40. Put this here. And say Atem and Rust dash hash 0003. Right? Simple as that. Wait, what the? Edit, redo. Okay. So let's just flatten this and say add alpha channel, add layer mask, grayscale copy. It's not nice. It's not even supposed to be like this, but I just need test data. So could you just remember the working directory, please? So we said this is banner title. Banner title, and we just export this as PNG. Yeah, defaults, I don't care. So banner title, same position afterwards. So Let's just see what happens if we run this. So we nearly have a stream banner. And then the scp -r. We copy this over, we copy the config file over, we run it on the Pi. We have our stream banner rendered on the Raspberry Pi live in Rust, overlaid on external hardware, ignoring the broken alpha and ignoring the lousy edges of the Atem. It's almost if there's some, it's hard to see in the stream probably, but it's also almost if there's a banding effect that flips the order. It's I'm not sure what's going on here. This pattern here looks weird. But I know what we're gonna do next week. Well, not next week, actually on Thursday. I know what we will be doing on Thursday. And that is... I like this so much I just leave it on now. Don't you? I know what we will do next, and that is text rendering. So obviously I just want, if I go to the config file and just go to the bottom here, I say name, banner, title, type, text, parameters, pos x is 10, pos y is 650, width is, I don't know, what did we say, mine's 60, height is 50, size is 40, and text is Atem and Rust dash hash 0003, and the hash here is actually ugly, so what I'm gonna do is I'm gonna force this. Probably we should force quote all strings, but let's remove some of the noise. But basically this is, hey, render some text live. I mean, if I run this now, it's not gonna work. I mean, if you look here, the parser got it. The parser knows what to do, but we are getting skipping unsupported element type text. But it's so super flexible that we can just configure this. And still, we don't have to use it as a stream overlay. We can use it as an information gadget for our desktop, or as rendered to a smart screen, or we could even, instead of having a window, we could render to a file, to an image that we update every X minutes, and then put that in a web browser. Or we could even render it and load it in OBS. So all this mess I have to do with a stream overlay here and the Streambox is all gone. I like this, and this text file is you just write it down and you don't even have to think about it. I like that. So that being said, it's still running. Sorry, I'm having fun here. So git add to do add image element and add test data for image element. That's all? Did I forget something? I know. So rebase, git push, in your face, or in this case, in my face. Yes, this is OBS still doing the overlay, so it's behind my face, but I really like this and I need to practice pointing for my stream. Oh, this is perfect. This. Oh man. So with this, I'm saying goodbye. See you on Thursday.